So in this video, we're going to be talking about how do we transform the quadratic parent function. So before we start, let's talk about what is the quadratic parent function. So if you remember when we were talking about lines, the parent of the line was f of x equals x. Now, the parent function of a quadratic is just f of x equals x squared, because if you remember, the squared is what's going to make it into a quadratic. All right, so let's talk about the main points that would go in this. First of all, if I plug in a 0, 0 squared is 0. So the very first point that we're going to actually have is 0, 0. It's going to actually be here on the, let me try to make this as best as possible. It's going to actually be here right in the origin. That's one point. Now the next point, when I plug in a 1, 1 squared is 1. So we're going to have 1, 1. Now another point that we're going to have is negative 1, 1, because if I square negative 1, you get a positive 1. And then if you plug in 2, 2 squared is 4, so 1, 2, 3, 4. If you square negative 2, you get the same thing, which is positive 4. And so this is what the graph of the quadratic parent function looks like. I'm going to go ahead and put it together. And then go ahead and put arrows. So this is just a quick sketch of what that would look like. So if we notice, the vertex is actually the origin, 0, 0. The line of symmetry is actually the y-axis. So those are very important key features. Now, what we're going to do to this is we're going to make it into different quadratics by doing certain transformations to it. So the first transformation that we can do is we can take the function and add a value k to it. So now let's remember what our function is. Our function is f of x equals x squared. So our function is x squared. If I take x squared and I add a number to it, if you remember, that is going to make a vertical shift up. If I take x squared and I subtract a number from it, it's going to create a vertical shift down. Now, if you take x, add a number to it, and then square it, that's going to create a horizontal shift to the left. If you take your function, your x, and subtract h from it and then square it, that's going to create a horizontal shift to the right. Now, it's important to note that with your horizontal shifts, it's actually the opposite of what you think. So if you add a number, you actually go to the left, you go to the negative sides. If you subtract a number, you actually go to the right, so you go to the positive numbers. The reason for this is because when I'm dealing with x, right, you would be solving and going backwards for it. So this is pretty much has to do with the transformations which we've been doing with all functions. And so the next transformation I can do is I can multiply it by a number. Now, it really depends if that number is bigger than 1 or less than 1. If it's bigger than 1, so not a fraction smaller than 1, then it's going to look like a x squared. And what this is going to do, it is going to stretch it. So let's kind of draw out what stretching looks like. So it's going to look a lot like it's been stretched vertically, a lot taller. Again, think about it. It's going to go up at a faster rate, so that's why it's going to look that way. Now, if you multiply by a number that is less than 1, so let's suppose that this number is a fraction like 1/2, or a decimal like 0.75, that's going to compress it. So compressing looks like this. Kind of looks wider. The reason for that is it's growing at a smaller rate. So that's why it's going to look that way. The next thing you can do is you can multiply it by a negative number, by a negative 1. And this is going to look like negative x squared. And basically what it's going to do, it's going to reflect it across the x-axis, or it's going to flip it. So instead of going up, it's going to go down. And then the next transformation you can do is you can take the x and make it negative and then square it. But what happens when you square a negative number? Well, it becomes positive, so it's still going to be x squared. So this is what we call a reflection across the y-axis. And if you remember, our parent function is symmetrical on the y-axis. So if you reflect it across the y-axis, you get the same exact thing. Nothing really happens to it. So this transformation, I just put it in there so that you can be aware that it doesn't do anything. You kind of keep the same thing. All right, so now let's look at what a question on this would look like. So g of x is given by 3 parentheses x minus 4 squared plus 2. What transformation was done to the parent function x squared? So there's a couple things going on here. The first thing that I have here is this 3 that I'm multiplying the whole thing by. So that 3 is basically going to, if I look back at my little cheat sheet that I made here, I'm multiplying by a number that is bigger than 1. It is creating a vertical stretch. Vertical stretch by 3. Okay, now let's go ahead and look at this minus 4. So I'm subtracting 4 from x and then squaring it. So if you remember, subtracting from x, that's going to give you your horizontal shift. And your horizontal shifts are always the opposite of what you think of. So because I subtracted 4, you actually went to the right. Shift 4 units to the right. And now let's look at the last thing that we have going on here, this plus 2 at the end. So this is being done to the entire function. So again, I'm adding 2, and if you remember and look at the cheat sheet that we created, if you add a number to the function value, then it's either going to go up or down. So we're adding here, so it's going to go up. So it went up. Let's use a different color set. Went horizontal shift up 2 units. Okay, so now let's kind of graph this and see if we were correct in our observations. If there was a vertical stretch, it went 4 units to the right and 2 units up. So first we're going to graph our parent function, f of x equals x squared. And then we're going to graph our transformation function, which was f of x equals 3 x, let's look back here, x minus 4 squared and then plus 2. So if you notice, so the red is my parent function, the blue is my new function. It did stretch vertically, so yes, it became more narrow. It went, if I'm looking at my vertex here, so like my vertex started at 0, 0, but then it went up 2 units and across 4 units. So our observations about the equation were correct. All right, so this is the end of this video, and I hope you found this helpful in terms of the transformations that can be done to a quadratic function.